Hi everyone, and a warm welcome to this webinar and workshop about reference and limit values for carbon footprints of buildings, a Nordic perspective. This event is arranged by Swedish Life Cycle Center together with the Nordic Working Group for LCA Climate and Buildings. And today we will have both opportunities to listen to presentation about research done to find reference and limit values, but there will also be chances to take part in group discussions within the same topic. Before I leave the floor to Matti Kuitinen and Anders Jensen, who are the chair and co-chair of the working group, I will go through the agenda and also give a short background and introduction to Swedish Life Cycle Center. And my name is Maria Rydberg, and I work at Swedish Life Cycle Center as a project manager. First, we have gotten used to these digital meetings, but a quick reminder, please keep your microphones on mute, and we will take questions after the presentations. You can use the chat for communication during the webinar. And when it is time for questions, please raise your hand with the raise hand tool or write your questions in the chat. The presentations will be found afterwards at our event page in the calendar at Swedish Life Cycle Center's webpage. And there will also be a recording available on YouTube. We will cut out the question part, so don't hesitate to ask questions that will be cut out of the recording. This is today's agenda. First, me and Anders will give a short welcome and some background about both Swedish Life Cycle Center and the working group. Then we will listen to Tove Malmqvist from KTH and Panu Pasanen from One Click LCA about research done to find reference and limit values. After that, Tove and Panu will be joined by Olafur Vallevik from Icelandic Building Research and Harpa Birgisdottir from Aalborg University in a panel to further discuss reference and limit values. After the panel, we will move into breakout rooms and discuss reference and limit values together. And we will meet back for short reflections after the workshop. So, just a brief background about Swedish Life Cycle Center. We are a competence center and collaboration platform for academia, industry and research institute, as well as government agencies. And our aim is to work for credible and applied life cycle thinking globally. We work for the integration of life cycle perspective into processes and decision-making within industry, government policy, and also other parts of society, with the overall aim of developing products and services with increased resource efficiency that enhances sustainable consumption and production patterns. And that also contributes and works towards a more circular economy and also the work towards our common sustainability challenges and sustainable development goals. We are a partner-driven collaboration that started 25 years ago, 1996. At the moment, we have 14 partners. They're on the left side of the screen, and 9 government agencies that are collaborating with the center. They are on the right side. And our network involves more than 400 life cycle professionals. Chalmers is our host. That is where me and my colleagues are employed. And of course, there's always room for more organizations. So if you're interested in what it means and what benefits there are in being a partner to the center, please contact me after the webinar. Very briefly, what we do. We are actually in one of these dots now, the webinars and seminar dots, and I will not go through all of them, But instead, I will encourage you to visit our website to find out more about our ongoing research projects and perhaps our 2-day course for applied life cycle thinking and our other working groups where life cycle professionals can meet and share knowledge and learn from each other. But with that said, I will leave the floor to Anders, who will present the Nordic Working Group for LCA Climate and Buildings.
Thank you, Maria. Let's see if we can get the presentation to work. Can you see my screen now?
Looks good.
Looks good, great. Welcome everyone. My name is Anders Jensen and I work at the Danish Housing and Planning Authority, and I am the co-chair of this group together with Matti Koitunen from the Ministry of Environment in Finland, who is the chair. I would like to start by giving a bit of background for our working group and for the network. There we go. So it all started back in 2018 with a declaration from the Nordic Council of Ministers, and this declaration emphasized that the Nordic countries should share a common goal of promoting low carbon emission in construction, and that we should work for harmonization of the building regulations between the authorities in the Nordic countries. This declaration was the background for an initiative from Finland and Sweden to set up the first Nordic Climate Forum for Construction, which we had back in October 2019 in Malmö, where the main target was to launch the work for Nordic harmonization. The same month, there was a new declaration from the minister, which highlighted the Nordic countries can benefit from sharing best practices, and that we should continue the collaboration and the harmonization effort. The declaration also had a call for all stakeholders in the construction sector to support the joint Nordic effort, which I must say that you have answered this call. So thank you very much for supporting our work, and thank you for participating in our webinars and conferences. Then in 2020, we had the second Climate Forum for Construction, which we, due to the coronavirus, had to have digitally. At this forum, we got valuable inputs on, among other things, the generic database and the future regulation in the Nordic countries. But let's hope that we can have the next year's conference physically, this year's conference physically. So how are we organized? We have procured Maria, as he said, from Swedish Life Cycle Center to organize and facilitate the network, which consists of a working group, which is a smaller group, and a wider dialogue forum of stakeholders, and it's open for everyone. The working group is a forum for experts with a focus on LCA and policymaking, and the participants are from Nordic authorities, academia, and industry. The goal of this group is to exchange experience with the aim of facilitating the Nordic collaboration. And the Nordic Forum is a wider forum consisting of webinars like the one we have today, which allow us to communicate the knowledge from the group, and it's also a forum where we encourage a wider community to give feedback on the work. We also have a project website on the Swedish Life Cycle Center's website, which I have linked to on the slide, where you can find summaries of what we have gotten out of the various events that we have, and also post relevant reports and studies about the harmonization efforts and LCA in general. So it's definitely worthwhile taking a look at this page. So what have we achieved so far in our group? The program for the working group has been updated this spring, and then we have also identified some key areas of harmonization. And there's also been a collaboration on the Nordic database, which was driven primarily in Finland and Sweden. And then we have also had discussion on the development of assessment methods. And in March, we had a very interesting talk with the working group on how to define carbon neutrality in the Nordic countries. All right. That was a short overview of the work. Now I have the pleasure of giving the floor to Tove Malmqvist from the Royal Institute of Technology in Sweden, who will present a Swedish product on reference value. Tove, are you here?
Yes, I'm here.
Great. Thank you so much for joining us today. And the floor is yours.
Thank you. Just start sharing my screen here. And like that. I hope you see it well in the right mode.
You see
It looks good.
Perfect. So thank you very much for inviting me, and hello everybody, nice to be here today. So I will talk about this ongoing project that we're working on for Boverket on reference values for climate impact of new buildings. And we started this work in the autumn, and we will actually not come with a report until the end of September. So this means that we are like in the middle of our analysis right now. So I have not promised to show, and I cannot show any sharp results from this study yet. But I hope to be able to provide you a good description of the project, and also to provide you an understanding of what will be the output of this project anyway. So the main aim was to develop and propose a methodology for reference values regarding climate impact for new buildings, and also collect background data on buildings to be used for this development, and propose reference values. And here we actually have multiple aims with these reference values. So they aim to both provide a support for setting climate requirements in procurement beyond legislation. Another idea with this work that we do is also to create a kind of baseline for being able to follow up climate impact on new buildings over time in the Swedish context. And finally, of course, also provide a basis for if limit values will actually be connected to the coming climate declaration regulation. So that's some background, and I'm doing this work, leading this work for Boverket, but together with WSP, Sara Borgström, who does most of the work, I would say, in the project. And also we collaborate with Martin Erlandsson at IVL. So we are the working group here for this project. And first, maybe I can just say that we have been in the work reviewing different ways to come up with similar reference values, but it was decided quite early in the project that we would focus on actually trying to make a more systematic study, compiling a larger number of building data to be used for the development of reference values, to actually also be able to look at what is the variation in climate impact for new buildings in contemporary construction in Sweden today, because we didn't have such material in Sweden before. Yes, so we decided to focus on 5 main building types in this sample when we are collecting data for the buildings. So multifamily, single family buildings, offices, schools, and preschools. And we've done some attempts to also include commercial properties like external shopping centers, but it hasn't been that successful so far. So we had a very broad call for buildings, and still we had been working with quite much to try to reassure that we really get common contemporary building solutions represented within each of these building types here. And as of today, I think actually this figure has risen. I think we have 69 buildings now that has been processed. So of course it's not a large sample, but it's still much better than we've been having before in Sweden at least. In the work we have also looked at the current statistics of how new construction looks like in the building, because we had an idea that if we see that our sample become biased in some way, maybe we need to work with trying to adjust the reference values in some way. But in the end, we, for example, managed to include 4 timber buildings, preschool timber buildings here in the end, to make sure that it's more representative for how current construction looks like today. But this is just an example here I show. Yes, so what will the reference values represent then? So in this current project, we are only looking at the life cycle models A1 to A5. And the reason for that is, of course, that this is the main focus of the coming climate declaration regulation. So this is of most interest now to have a closer look at. But of course, we have material, so it's impossible to also calculate other life cycle stages later on. But in the current project and until September, this will be the focus. We are working with 2 system boundaries for building parts or building component coverage here. So one is the system boundary that the coming regulation will, how it looks like when it's installed in 2022. Main building elements, so the load-bearing structure, climate shell, inner walls, and potential basement and garage. But we are also looking at the system boundary, which is to represent a more complete inventory of the entire building. And that is actually also has been proposed as a suggestion for developing the climate declaration regulation in 2027. And here it's primarily to add interior finishes and technical installations into the calculations. We're working with average generic climate data from Boverket's database, and this has not been, it's still a pilot version, so we have been really trying to be flexible to make sure that we get the latest changes from this database into our calculations. But we work with average data here because we wanted our reference values to better represent how it actually looks, the construction out there, and not these conservative values that are in the database. We are also making a calculation that we call best practice. So one way of trying to set up a representation of what can be done already today. And this is done by replacing a few of the data sets here to more greener alternatives. And apart from that, the calculation methodology follows the coming regulation. So I will stop a little bit to talk about the background data here, because actually this project has become like that we have had a very high focus on working with compiling and processing the background data, that is the building inventories for the calculations. So we had a very high focus on trying to establish a uniform and high quality data set here, methodology, to really make sure that we have control over the background data to the highest extent possible, and also the possibility to set up the same calculation methodology. So we have not been asking for ready-made calculations. Instead, we have asked for high quality bills of resources of these buildings. And we also set up very high requirements on these bills of resources from the data providers here. Here we have asked for them to be based on cost calculation data in the first place, to really make sure that we have very complete inventories, and also as close to as built as possible. And this is also done in relation to that we wanted to set up a method that is really compatible with how this is going to be done later on for the climate declaration regulation. We have asked for example, at least 80% coverage of the data, the inventory in relation to the system boundaries that we look at. And in the end, we have managed to reach more than 90% coverage for most of the buildings we look at. We also had a very uniform ways of processing the provided data. So make sure that the mapping of data and conversion of units to kilos, etc., has been done in the same way, and how to compensate for data gaps, that is done in the same way, for example. And finally, even though we set up high requirements, I can say, for example, that we we have excluded a lot of buildings because we felt that they didn't really meet our initial requirements here. But despite that, there are, of course, particularly some components or parts of the bills of resources here that has a lower quality. So in this work, we have also been developing new standard values for some parts, and this entails interior finishes and technical installations and the on-site energy used in module A5. And this, I would say, is not perfect, but it's at least one step forward in the Swedish context of trying to set up quite solid standard values. And just to give you some kind of hint here on this quality control process. So we have in the left lower corner here, this was the first graph we took forward, and in the other corner with the blue bars here, we have the near to final diagrams for the buildings here. And as you can see, in the first one, we had buildings that were up to 1,200 kilo CO2 equivalents per square meter. And now we have the highest a bit above 400 instead. So we have had also a process where we have really looked neatly into the values, looked at into different building parts, and also to make sure that we see that the building parts are, so to speak, filled with information, and also looked at, for example, if the amounts of kilos for different building parts of concrete, for example, seems reasonable, things like that, to try to set up this process. And when we have detected errors, we have always got back then to the data providers also to ask them to recheck or come up with revised values, etc. So actually in this process, we had, I think, 23 buildings from the first step that actually passed this quality control to the last step here. And this is, I think, an important maybe added value of this project, that we have had a very close communication with data providers and really done some kind of educational job. We have had a lot of communication with very many developers in Sweden and property owners in Sweden. So hopefully we have contributed, I think, to kind of educate a bit in terms of what kind of requirements do we have to set on the background data here also to come up with robust climate calculations. And all the lessons learned in this data compilation and processing has also been feeded into the work at Boverket regarding developing the climate regulation more in detail, and is, I think, important lessons learned for working with how to set up the control in the end of the legislation. Yes, so of course we can do a lot of analysis now with this data we have. And one use of this is to come up with reference values. And this is just to give an overview of what I see the main reference values that will be produced here for Boverket. This will be actually average values for the different building types. And we are looking at these two different system boundaries, 2022 and 2027. And we also come up with this so-called best practice calculation, which means that we can give an understanding of if some of the most important materials were procured in a greener way already today in these buildings, how far can we actually reach improvement here. But of course, starting for the discussion later on limit values, etc., we can also come up with like quartile values, and we also look at per heated floor area. We also made such calculations, for example. And finally, I will just try to give some short, a preview of some short results and conclusions that we feel we can say already now, which maybe be of interest for the coming discussions. So we see that we have a very great variation, even though we look at a selected part of the life cycle, there's a big variation here in the results. And also great variation in all building types apart from the single family house buildings, actually. Here, the single family buildings clearly come out having a lower impact per gross floor area compared to the other building types. And also buildings with a lot of wood inside them also come out clearly as lower. And of course, single family buildings in Sweden are built primarily in wood. So that's also a reason for this building type to be a bit lower. We also look at an analysis of a couple of different building properties in relation to whether if to set certain strict limit values, would that actually disqualify buildings with certain functional requirements or so? And here, for example, we have looked at this, does a higher sound class or a more energy efficient climate shell, would that lead to a higher climate impact per in modules A1 to A5 here? And so far we cannot really see any tendencies of that in the material that we have. But of course it's not a lot of buildings we have, but still no such tendencies. I should finish now, I think, but maybe also say that in relation to what improvement potentials are out there, we can see that if starting setting requirements in procurement, for example, as percentage reductions, it's evident here since we replace concrete data and steel data in our calculations, but that's the first things you think about of trying to work with improvements. But here it's clear that, of course, the solution where we have a lot of concrete and steel can easily improve by 10%, for example, but it's much harder than for constructions where you have a lot of timber, for example. Yes, I think I'll stop there now. We see that this project will provide a lot of useful insights for both for working with low carbon construction and also working with climate calculations in the Swedish context. Yes.
Thank you, Tove. That was really interesting. And I will be now joining this meeting. My name is Matti Kuittinen. I'm from the Finland's Ministry of the Environment, and I will be chairing the rest of the meeting. And warm greetings to you all from EU's Green Week event, where I just got from and where we were talking exactly about the same things. And they were very curious about the process that's going on in the Nordic countries. So now we have heard from Sweden, and next it's time to hear from Finland. Mr. Panu Pasanen from OneClick LCA will talk about the experiences from the first calculation exercise done in Finland. So over to you, Panu.
Yeah, thanks. Good afternoon, everybody. So I'm going to talk about work we did for the Finnish government about the same topic, really. And just shortly about us. So we are a private company. Predominantly we do software, but we also think policy is quite important. So we do selective low carbon construction policy work. We are about 55 people and based in Finland. The work we did here is commissioned by the government. The findings here don't constitute government position, but what we think about it. And the latest update of the report is dated on the 1st of March, and you can find it on the government website. And I'm sure you can ask for it as well if you want. What we did in this project is we did more or less 4 things, we can say. We did statistical analysis of projects. We analyzed both buildings which have already done, real buildings that have been done in LCA before. We studied energy performance certificates, We created reference models for 5 building types, and then we analyzed all kinds of reduction methods and sensitivity analysis scenarios on those reference models. So unlike, I think the biggest difference here is that we sit on really a lot of data. And I don't know exactly what is the amount of projects we have, but I would say it's well over 700 that we have in total. So this is just the subset of projects that we retained for Finland. I mean, obviously it's much bigger, broader. And we took the qualifying part of the actual building LCA process for Finland. And then we got from the government agency looking after energy performance certificates. We got all the energy performance certificates between the date of the beginning of the project and the date of the revision of the energy code, because the energy code had been revised at a certain point in time. So all the older data would have not been useful. So that's about 2 years worth of data or something like that. So it's obviously for energy performance certificates, it's everything, and for the embodied carbon, it's a sample. And then I will talk about the rest a bit more detail as we progress. So we did the study in a few different ways. So we started to look at variance of the assessments. Then we analyzed and calculated out all the potential deviation sources. One of them is the foundation conditions. So we did the data separately with foundations or without foundations, so we can actually see what difference does it make for the total figures. And the foundation question here is particularly relevant, of course, because it may be a choice that the government makes to include or not to include it in the regulatory limit values, because it would reflect on the possibility to build on certain pieces of land. And we were targeting 5 building types, but because of course it may be that there will be some future regulations, we also did statistics for some other building types which were not in the scope of the study. If you look at the data, you can see that we have the 95% confidence intervals here. So some of the bands are pretty narrow because the data is quite consistent. The sample is fairly large, whereas in the others, where the sample is quite small, there's quite a bit of bandwidth within the confidence interval. Oh, and one more thing I will say. So we don't have much concern about the data because obviously we can access all of it and we can eliminate everything from the sample that we don't believe in. So then the second part is we have actual buildings, and then the question is, how do we make these scenarios? And to make these scenarios, we need something which we can easily model. We can't go and build adjustments to the actual buildings. That would be not feasible with the time we had at hand for this project. So we created reference buildings. Reference building idea is something I think originally developed in Norway. Quite a good idea in a way. And it's basically a most typical building you would build for a building category. And we created the standard reference buildings basically for each of the categories, parameters. They are documented in the report. They were created with an early phase design tool called Carbon Designer. And then we use these reference buildings for each building category to create all the variants, which allowed us to have a, let's say, a feasible approach to doing the what-if scenarios. And when we normalized the reference buildings for 50 years per square meter, including the handprint, which is in the Finnish methodology a negative figure, we ended up in figures between, a bit over 10 to about 18 kilos per square meter per year for service buildings, which have a very bad energy performance in the Finnish building system as of today, on the average, I mean. And what we did then with the buildings is that we calculated 2 particular areas which we felt, well, government felt and we agreed basically, would be of regulatory concern. The first is out-of-scope elements. So if regulation chooses to exclude certain things, what will it mean for the purpose of the regulation, which is to reduce carbon footprint of the built environment? So the out-of-scope elements turned out to be very big because in many of the Finnish cities, they have been built next to rivers as everywhere else, basically. And that means we have very interesting clay pits. So we have a lot of clay, and to build on that clay we have left, because all the good building spots have been built already, there can be very heavy foundations. And the out-of-scope elements impact was done for all building types. And I think this is quite useful exercise to understand what you should not exclude from your system, or what you need to actually require to declare if you don't set a limit value for it. So I would encourage to consider this also in other Nordic countries if you're planning regulations. The other is parking systems besides the foundation. So parking systems can have a very significant impact, obviously. And then we have a few things which are related to the location or parameters like that. So in the Finnish system, zoning can require that you build a brick facade, for example, that you have balconies. And we may have other parameters which are dictated by the zoning. And not all of these sensitivity analysis scenarios are zoning driven, but some of them are. And we calculated also all of these because from a legal point of view, we felt it's essential that the regulation can be implemented in every context that's possible within the Finnish legal system. So if you have a municipal zoning in vigor that requires you to have a brick facade and to put balconies, and where you have no common air raid shelters, and where you have some other things as well, you should still be able to do it. And then we analyzed some carbon reducing measures. We analyzed just 5 measures, and we analyzed measures which are not design specific, not let's say good ideas or anything, but which are like macro level measures that can be scaled. And in energy system, we just analyzed 2 measures. One of them is A, energy class, and the other is ground heat pump. So when we set the proposed reduction targets for the building types, we can see that in most building types, energy measures alone do not hit the reduction target that's proposed. This is basically natural because we did set the targets to be ambitious, so that they would require a combination of different measures. And when we look at the material choice measures, we analyzed 3 scenarios here. One of them is low carbon concrete, another is timber frame, and another is CLT frame. We didn't analyze low carbon steel frame. It's not also something you can use for all of the building types in question here. So wouldn't be doable. And we can see that also the material choices themselves don't cut it. So for this system, which encompasses both, every project would have to combine improvements on both fronts if these limit values are retained, or if this level of reduction is retained, let's say. But anyway, seems clearly feasible, and there are multiple methods which you could use, or multiple methods that you combine to achieve these limit values, which is important to provide an open market, which doesn't require that a certain technology or material or system is used to be able to build. So it's market-based system in that sense. And finally, we ended up with proposed limit values. We started with the reference figures, variance outside project's control, and then the proposed decarbonization, which was proven to be feasible for the building type in question, which was between 20 and 30% by building type. And then we rounded the figures to, a bit simpler numbers, and our limit values are from 10 to 40 kilos per square meter in carbon footprint. Carbon handprint is not deduced, it's reported separately and not part of the figures. However, the government is updating the methodology and has issued in March, as it is, a generic database. So because the study was done before these those are not reflected yet, and this work has to be updated prior issuing regulations. So, so much for that. That's it, I think, for the Finnish study. If you're interested in benchmark figures for Finland and Sweden, you might also be interested in this. So, because we run out of things to do in March, well, not really, but this was quite interesting exercise. So we decided we would do embodied carbon benchmarks also at the European level. And for this one, we took about 15,000 building LCAs, but we eliminated a huge number of them based on different statistical methods. And we retained about 3,700. And we grouped Europe into 3 regions and 5 building types. And this data is going to be freely available for anybody who wants it on next week, Tuesday. So there's a webinar about it as well. So maybe it's interesting for you. Also, we are going to be updating some other research which may be of interest for you. It's called Embodied Carbon Review. Just the little issue we have at the moment is that we would like some sponsors. So if you are one of those, please reach out to us. And that's it from my side.
Thank you, Panu. Interesting stuff, as you could all see and hear. So now before we jump into the reflections from the panel and before we go into the workshop, there is a chance to go through a couple of questions. And if Tuve, if you can also join us in these, in responding to these. So I'd like to pick from the chat. Thanks for submitting questions there. I would like to address Tuve first with the question from Ingerid about if you could explain how a building with a higher sound class doesn't lead to higher climate impact. So Tuve, can you elaborate on this? And then I would like to also hear from Panu if you have had any views to this.
Yes, I can start. So, I mean, what we did here was that we didn't really, of course, you could choose to study the particular building elements and compare, and maybe we would see a difference here. What we did was that we wanted to study the total values from A1 to A5 for the whole building, the system boundary that we worked with, and then compared buildings with higher or lower sound class. And the reason for doing the comparison like that is if limit values would be introduced, it will be introduced as a not looking into particular building elements like that. But of course, we don't have at all as many buildings as Panu, so it's tendencies here, but we couldn't see any clear differences when looking at the whole building results.
All right, Panu, any views from your side to this?
Not in regards the specifically how you asked about it, but we did some benchmark for different acoustic insulations, and we compared about 10 acoustic insulations, and material choice can certainly reduce that. So I would not imagine that improving sound class on its own would make anything impossible. It might require you to work a bit harder on some choices, but I can't prove it like in the way you intended, in the intended sense of question.
All right, so then let's pick one more before we get into the wider Nordic panel discussion. Maybe then there is a lot of like more detailed questions in the chat, so I wonder if Tuve has time to answer to some of those. But I would just maybe like to touch the topic of the so-called Module D, or the potential benefits that could happen beyond the system boundary. And there's a question addressed to you, Tuve, that is, have you got any plans, or what sort of discussions have you had regarding excluding this so-called Module D from the method that would be introduced by year 27? How do you see this?
Yeah, I mean, this has been a long discussion during the development of the regulation. So, I mean, in the end, this is the proposal in the regulation. And I mean, one issue here is, of course, that the regulation is trying to really target the issue of the emissions happening now when we have the new construction. So that's one issue. Another issue is, of course, I mean, from my perspective, it's also about trying to set figures on this module D. Of course, it should be reported separately in that sense, and not included in how we calculate the impact for modules A1 to A5 or A to C. Yeah, I don't know, we can talk about this a long time, of course.
That could be a long discussion, but that's actually something that could be continued as a Nordic discussion. And let's see if the other Nordic experts have anything to add to that. Now I would like to invite to our panel Harpa Birgisdottir from Denmark, and then Olafur Vallevik from Iceland. So let's try to get you here into the same show. Just a second. And yes, so welcome. I hope that I've got everybody covered who are about to join the panel. So, but let's start by giving the screen to Harpa and Olafur, and if you could kindly, in a few words and a few minutes, explain your view and your work in this field, that what you have been doing in your countries. Shall we take Harpa first, please?
Yes, hello. So. Thank you for inviting me. I'm Harpa Birgisdottir from Bill, from Aalborg University, and we have been working with calculating benchmarks as well, and the climate impacts of building for Danish cases. And I have presented earlier for this, in a similar workshop, our results of from our report of calculating 60 building cases, a report that is available in Danish and English, and I can put the link to that in the chat if there's interest for that. So yeah, we have similar tried to figure out what is the range of the climate impacts of buildings in Denmark, and our task, which we got, this project that we got, was to try to cover that based on building cases that we could collect and calculate, similar to what Tove is presenting, what they are doing in Sweden. So we didn't have the access to as large data material as Panu was presenting, and that was both like trying to both cover, you know, for building, we were working with office buildings and residential buildings mainly, and to try to cover a range from low to high. But of course, there could be situations where we, you know, there are still some that are lower and some that might be higher from the data material that was available, and also to look into different, you know, looking into analysis of you know, what is impacting the results and so on. And what we calculate was like the total life cycle. So it was both the phase A, B, and C, and we didn't at that point of time include then the module D in it. I think now we have a test phase in Denmark of the voluntary sustainability class, and that will then also include calculations of module D. But just to sum up also, now there is a regulation in place in Denmark, and it will start in 2023, where all new buildings are obliged to do, they should do an LCA, and the ones that are larger than 1,000 square meter have to fulfill a limit value. And that is, you know, this limit value is based on the results of the report that I discussed. So Matti, did I forget anything important to say?
you can get back to those things that you may or may not have forgotten. But now let's jump to Iceland. Olafur, please let us know what's happening up there. You are having an interesting development in these aspects as well, I believe.
Yes. The recent 1 or 2 years, we have had relatively few life cycle analysis until now. Of course, because of BREEAM, which we are mostly using for bigger buildings. Then there is a requirement of LCA. The building authority has established quite comprehensive work where there are 6 groups who is evaluating the environmental impact. And this will be connected hopefully to the Nordic work. I'm in group 6 of those who is about how do we estimate emission from the building industry. We have in this work, the other groups are mostly related to A1 to A3, 1 to A4, 1 to A5 on the building construction site, and so forth. So we have made an estimate, even though we have very few LCA analysis here, and we tend to build a little bit different, meaning if you take a single family house, then at least I said in my lecture 2011 about, then 90% of single family house in Iceland was made with a bearing construction of concrete, as it was the opposite in Norway, approximately. And that's easy to understand. What we have around us is sandstone and water. So we needed only 10% volume glue or cement to make a house. As the Nordic countries have built their buildings nearby the forest. We have done, I see that there is a quite big difference of the classification of the buildings, but we have classified the buildings into 10 categories, where the in square meter, more than half are single family houses, multi-family houses, or summer houses that you can stay in all year round. We have estimated for each of those 10 classes, then we have estimated carbon, which we have here, but we have still some kind of an issue. But we have really started, at least, with full effort.
Okay, that sounds really interesting. So the LCA is gaining more ground in different Nordic countries, which is great. Now,
yeah, I want to add, I'm not sure if it will happen before 23, like in Denmark, but likely we will get some kind of mandatory demand of LCA within 3-4 years. And we will have a classification of the carbon footprint per square meter likely before 27.
Oh, this is great. It's like breaking news. Iceland to set a mandatory greenhouse gas limit for buildings. This is the first time I hear about this, so I'm very excited. I need to check this immediately with my authority colleagues. So that's going to be interesting. And while we are at it, I can also share with you the news that Estonia is also about to start looking into these things, and they have started a project in which they are looking at the methodology and possibilities for legislating these things. So it looks promising. But now, next, let's have a round again. And now I would like to have very brief comments from your side. So I would like to hear from you experts that how do you see from your own personal perspective, what should be done in order to get comparable results for buildings between the Nordic countries? Or is that even necessary? So what should be done? Or do we need to do anything? It's just okay if everybody's doing things in their own way, which is of course the best, obviously. But I know that, Panu, you are always ready to respond. So I would suggest that you would start, followed by Tuve, Harpa, and Olafur. And please keep it short, since we are about to jump into the breakout rooms. Surprise. Panu, please.
Yeah, I can't see much use of being able to compare the buildings for the whole assessment. However, comparing core and shell on A1 to A3 basis, I think is eminently feasible. And that's pretty much the extent of the usefulness of the exercise, because the rest of the parameters vary so fundamentally in the methodologies usually.
All right. That was well compressed. Tuve, please.
Yeah, no, I mean, I agree. I think maybe the biggest work here has been to try to start driving the low carbon construction here, and then it has been important to do to stick to our national ways to do it, I think. But I mean, what has happened lately is still, I think that the calculation methodology now is very similar in all countries. So here we have really harmonized. So it's more a matter of how we tend to present results for A1 to A3, or with which system boundaries or so. So maybe that's what I can say now.
Yeah, and I can say as well that of course it would be really nice that we all calculated in the same way and could compare, but having been working with this for many years, trying to harmonize methods across Europe and so on, I think well, because we are in a we are in a hurry and we should decrease the climate impacts of the building. So that is, I have said it before, that I think that should be the first priority. But of course, it's really nice to be able, so that is a need to reduce it, and it's really nice to have it similar. And if we can try to have as many parts of the methodology harmonized, I think that is a good thing for us. But we need to understand that, yeah, it's always a good thing to like say, yeah, there's, well, across Europe, you're not using the same square meter even, you know, the definition of a square meter. Yeah. So when that is also a problem, then many other things are a problem. So maybe we need to accept that, that this is different.
I really mean that we should continue to do what our approach is. You can also see, when you see a bigger analysis of LCA's many studies, that there are many fluctuations in them. Also, if you would go to 3 engineering offices, one using GABI, one click, or one CIMAPRO, you would get different results. You see also there are results as the information gains, meaning if you make analysis today, you have much more negative carbon footprint from EPDs in plywood than for 5 years ago. So there are so many variables. So what we should do is to make a simple system based on A1 to A5, where we try to make some simple ground rule so we can compare. A simplified discussion.
Okay, so it's been proposed or suggested through the panel that let's focus at the beginning of the life cycle, as is the Swedish approach for the next 5 years. That's interesting. Now let's have one final round of comments from your side before we then go into the the discussion in the breakout rooms. And I believe that I'd like to say to everybody in the audience that we really would like to hear your views. So please stay for those breakout rooms. I know that everybody's quota is so full of breakout rooms, but I would like to suggest that please give your influence and your input still. But now, as we go forward in setting of these limit values, from your viewpoint, now I'm asking to the panel, what would you see the biggest enablers for setting the limit values and for managing them? To put it the other way around, what are the biggest barriers are hindering us from doing so? And if we could again take the same order, starting from Panu, then Tuve, Harpa, and ending at Olafur. So the biggest enablers or the biggest barriers from your viewpoint to the limit values?
I think the biggest enabler and limit basically, or barrier, is at the same time the cost and quality of assuring the results are good. Like, we are very far from the point where energy performance certificates, which exist since 50 years, that actually represent the actual building still. So we are not probably going to get perfect data out of LCAs either. So we need to calibrate the usefulness of the data, but without leaving obvious abuse gaps into it. I think that's quite important for the market to function.
Thank you, Panu. A little bit of difficulty there in the connection, but as far as I could hear, was the quality and the ease for controlling the quality. Something into that direction. Tuve, please.
Yes, and that's a bit what I tried to bring up in my presentation as well. I think it has been a very clear learning lesson. Of course, we know this from before, but it's still a lot of job and also, of course, can be related to costs then to come up with good background data. So I think, I mean, it is of course a challenge of introducing limit values in the legislation as soon as they become sharper, in order to also make sure that it's not the good ones, the good guys, the good calculators who include everything in the buildings who will actually be, come above these limit values in the end. We had a discussion this morning also related, I think it's talked about this. We can see, of course, that there are opportunities to reduce impacts a lot just by, for example, replacing to greener concrete and similar things. But as soon as limit values should become more strict or sharper, then we really also not need to start to consider the issue of goal conflicts with other functional requirements, and make sure that we don't disqualify buildings that we actually want to have out there, of course.
Yeah, that's an interesting take on the possibility of policy as a subjective instrument to steer towards a built environment that we wish to have. Harpa, what do you think about the greatest enablers or barriers?
Yeah, if I should just then add to what has been said. So I think, of course, we all here in the panel and people attending here, many of us are really working hard on trying to increase the knowledge about this within the built environment, the value chain within the built environment. We are trying to develop methods and as tools and knowledge about how to do it. But still, of course, if we would look into a barrier, then of course there is something that there is, of course, the lack of knowledge throughout the whole value chain. And if just to mention that, so this is then going to be also a requirement for smaller buildings where you usually don't have large consulting companies helping you out and so on. So that is one barrier just to mention, not on the highest priority maybe. But then also to support the quality of data and so on that both Panu mentioned, but also Tove, and that it's also a problem for the ones that are trying to do their best and take everything into account. They are then punished by having to, have all the details within the building, because it can be difficult to check exactly if everything is within. So it has to be a lot of trust in this. So that also, so that is also something that needs to be worked on now, how to make sure that that what is reported is of similar details and quality. And I think there will be, due to cost, there will be a lot of need to work on simplifying the approach even more. So that is just what I wanted to mention.
Yeah. So making it more robust and more accessible for all levels of different players. I think that really resonates pretty well with the Nordic ideology of making things equal to everybody. So that's a pretty good idea. That it should be a sort of like basic right for your company or for yourself to get an understanding of the carbon footprint of the house or the cottage that you're about to build. But let's end our round at Olafur, please.
Yes, thank you. In many ways, I agree fully with Harpa, but we need to increase the understanding, because that will be the barrier, especially if we put it into the regulation. There will be so many new who are making these analyses. And for many of them, the tool they are applying is just a black box. So to get the quality data, you have to increase the understanding. The second area, I actually propose that within this group that we would try to do like a round robin test, meaning we have certain information to our group in Nordic, maybe one or two in each country, and we would have a certain data and see how it comes out for various institutes, round robin test. Because I think the biggest problem is to get very accurate input data.
Yeah, that's a really good idea, the round robin test, or meaning that there are lots of different consultants who are taking the same data in or the same building in and analyzing its carbon footprint and then comparing the results with what are the differences. So please be informed that there is a forthcoming Nordic project about life cycle assessment and data that should have been starting already this spring, but there have been some delays due to the COVID pandemic, but it's going to start this year, and there we have possibilities of also looking at these sort of things. Yeah. Now, before I invite Maria Rudberg to inform about the breakout rooms, I would like to thank our panelists. This was great. And also thank everybody for the great conversation that's going on in the chat. Maybe would like to touch something that Jakob Rörby just mentioned about the energy performance of buildings directive, although he didn't directly mention, but there has been discussions that, as we know, that the directive for the energy performance of buildings, that's under revision, and it's being discussed that should actually we have life cycle assessment or whole life carbon assessment embedded into that directive. And if it was, then of course it wouldn't be just up to the goodwill of governments to consider if that would be used in different countries, but it would be mandatory for all the member states. So that's an interesting possibility as well. Now, thank you to the panel. And then now I would invite Maria to join us and explain that how are we going to go forward.
Thank you for watching this webinar. If you are curious about the Nordic Dialogue Forum for LCA Climate and Buildings, you can find more information on lifecyclecenter.se. Thank you for watching this webinar. If you are curious about the Nordic Dialogue Forum for LCA, Climate and Buildings, you can find more information on lifecyclecenter.se under projects.